What's up, B2 Geometry? This is Mr. Bivens here. Hope y'all are doing good. I'm currently at an award conference, so hope you're not missing me too much. This is going to be a lesson for the day, so I'm just going to walk through our homework from last class from 4.8 and then go through our lesson so that you still have some sort of teaching. So, some quick reminders. Your test will be next Tuesday or Wednesday. For y'all, it'll be on Wednesday since you're my B-Day. Next Monday, we'll have our test review, and then we'll get our test. Reminder, your class has the front of a note card, a standard 3x5 note card. I'll be checking those before. And yeah, that's pretty much it. I'll give you a moment to get your stuff. So if you don't have your notebook out, your booklet, your pencil, and your earbuds, go ahead and pause the video now and get that out. All right, now that you've done that, we're going to walk through the homework first. You had 4 problems, starting with number 2. Then you had number 3, number 5, and number 6. So, starting with number 2. What you were tasked to do in these problems is to figure out if the triangles are congruent. If they were, write a congruent statement and tell me why. If they're not congruent, then also just tell me why not. So, here's number 2, part A. And our very first question we're given is these two triangles, ACN and THE. Our goal is to figure out whether they are congruent or not. Let's look. I see 2 congruent lines here from HE and AC. I see 2 more congruent lines, HT and CN. And then lastly, they both have an angle in between them. So are these triangles congruent? Yes, they are. How do I know? Through side, angle, side. I have this side, this angle, and this side. And that matches up exactly with this side, this angle, and this side. For my congruent statement, I would probably say something like triangle CAN maybe makes the most sense. CAN is congruent to triangle. Angle C is the same as angle H, so I need to put H first. I go from C to A, so I need to go from H to E. Triangle H, E, T. And that's it. We're good for 2A. Part B. Can I figure out if these 2 triangles are congruent? Well, let's figure it out. I have a side. I have another side. I have side GD and side DB. And that's all they give me. You would think these are vertical angles here, but they are not. If this line extended out, this angle right here would be vertical to this angle. Do I know anything about the third sides? Nope. They don't even look like they're the same. And so I do not have enough information to say that these 2 triangles are congruent. So, very, very sad. I would need angle BDC right here and angle GDF right here to be congruent, to have side, angle, side. Or those third sides would have to be congruent, but they're not. All right, lastly. FD, I look, it is congruent to FW. I see the one little tick mark. That's what's telling me that. Then I have DK and WK. Those are congruent. I only have 2 congruent sides, so I might think, yeah, they're probably not congruent. But notice they both share this same side. And of course, that side is congruent to itself. So are these triangles congruent? Yes, they are. How? Through side, side, side. And so maybe you said something like triangle FDK is congruent to triangle FWK. Notice the K's are both at the end and the F's are both at the top. And so those angles will match up. FD is congruent to FW, and so we're good. That's number 2. All right, here's number 3. Consider these 2 triangles that they give us, and then in part A, they say what additional information is needed to say that these 2 triangles are the same only using the SSS congruence, meaning I need 3 sides that are the same. Well, what do I need? Well, I need those third sides, AN and XR, to be congruent. So I would need them to tell me that line segment AN is congruent to line segment XR. And then I would be good. But they don't give me that. Part B. What if, instead of using side, 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 I wanted to use side, angle, side? Well, my two sides that I see are there and there, and there and there. Side angle side says the angle in between. So I need angle C to be congruent to angle O. That's the only thing I would need. So angle C has to be congruent to angle O. And that is the additional information that we would need to prove that those triangles are congruent. All right, number 5. M is the midpoint of IH. What does that mean? That IM is congruent to HM. That was back from Unit 2. Next, they also say that M is the midpoint of JL. So that means that these two lines, JM and LM, are also congruent. That's part A. Part B, is there enough information to prove that these two triangles are congruent? Yes or no? Well, just from what they give us, it's not looking like it. But if you remember, vertical angles. These two angles are vertical angles, and this is going to give us a side, an angle, and a side in both triangles. A side, an angle, and a side. So yes, in part B, this is enough information to explain. Why? Because I wrote the word why. That's awkward. Because of side, angle, side. We could say that JIM and HLM are congruent. Last homework problem, number 6. Is this line segment congruent to this line segment? Well, they don't mark it, so I'm probably going to say no, but let's do some investigating. All right, side NO, I see one tick mark. That's the same as this side over here, SE. How do I know that? Again, they both have one tick mark. Next, angle N and angle S are the exact same. Why? They both have the same arc with one little tick, so they're congruent. And then lastly, NP has 2 tick marks, and so does SH. With this information, these two triangles have to be congruent. Why? Because of side, angle, side. Now, if I have 2 congruent triangles, everything about those triangles are the same. This angle over here is the same as this angle. This angle right here is the same as that angle. That also means that this side right here is the same as this side right here. So are they congruent? OP and EH? Yes, they are. Why? Because these are 2 congruent triangles. Everything about them is the same. When we get back to class, I'll give you the phrase that we're going to use to justify that. Good work. All right. Now, if you need to take a moment, you can take a moment and compose yourself, take a breather, take about 1 or 2 minutes, pause the video, and come back. All right, welcome back. We're going to continue on with our lesson on essentials only. So, thinking back to last class, what did we do? We explored 2 different ways, 2 shortcuts, some would say, that I can say that, yes, these 2 triangles are congruent. If you're listening, turn to someone next to you and tell them those 2 triangle congruent shortcuts. Wow, you did so great. Hopefully you said side, 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 and side, angle, side. If you said side, side, angle, or angle, side, side, you're wrong. We don't like those. But what we want to do today is I'm not going to walk through this entire lesson. Some of this you don't need. Some of it you do. And so if you want to use your pencil, we're going to work through some of these problems together. And then we'll go back in red and I'll give you the main highlights from different problems. So, here we go. Just giving some context, I'm going to read this top part. Mathematicians figure out what's essential and learn how to eliminate or ignore what's not. Yesterday, on Tuesday, we found that knowing just a few measurements were enough to determine if 2 triangles are congruent. Are there other essentials? Let's find out. No, the triangles in these problems are not drawn to scale, so you're not going to just get to eyeball them or use your ruler or protractor. So, here we go. Number 1, look at these 2 triangles. What is the same? What is different? Well, I notice all the angles are the same, but I also notice that all the sides are different. But I do notice a weird relationship. This side right here and this side right here, how did I go from 4 to 12? I multiplied by 3. That's weird. What about this side right here and this side right here? They also multiplied by 3. And then lastly, what about from AC, this side right here, to DP, this side right here? Well, again, we multiplied by 3. And so there's some interesting properties going on here. But let's note, these two triangles are not congruent. They have different side lengths. So there is no way that they're congruent. Let's work through number 2. Here's two triangles. Can I find the missing sides? Well, similar to the last problem, all of my angles are the same, right? The 52s match up, the 85s match up, and the 43s match up. They give me 3 sides over here and only 1 side over here. I wonder if there's a relationship between this side and this side. Take a close look. How would I get from 4.1 to 8.2? Well, I'd multiply by 2. So to go from 2.8 to this side, I would, very good, multiplied by 2. When I do that, I get 5.6. And then lastly, how do I go from 3.3 to this side? Well, just like I just did, let's multiply by 2. And I get 6.6. Now, are they congruent? There's no way these triangles are congruent because they do not have the same side lengths. We have a name for this, and we'll come back to it in a minute. All right, we're going to skip number 3 and move on to number 4. Number 4, can I figure out if these two triangles are congruent? Well, let's look. 35, 35, 115, 115, 30, and 30. So they give me 2 triangles with the exact same angles. Do I know if they're congruent? Well, let's look back up to number 2. I had 2 triangles that had the exact same angles, but they had different sides, and we said that those were not congruent. So no, I have no idea if these triangles are congruent. Why? Well, they look similar, but I don't know if we can say that they're congruent. All right, number 5. Is there enough information to determine if these triangles are congruent? Let's look. I have an angle, an angle, an angle. All of my angles in both of these triangles are the same. What about my sides? Well, I've got a side here and a side here. This is something you'd have to guess, but we are going to be able to say that these triangles are congruent. Why? Because of our first new triangle shortcut. Angle, side, angle. ASA. Note, last class, we dealt primarily with sides. This class, our theorems will deal with angles. You guessed it. And so yes, these triangles will be congruent. Let's go to number 6. What about this one? Is there enough information to determine if these triangles are congruent? Well, they have the same angles, the same sides, and the same angles. So yes, through angle, side, angle, these are the same triangles. All right, what about number 7? I have 68, 57, and a 9. I have a 68, a 57, and a 9. This looks interesting, and this is going to be our second main theorem and our last shortcut. It is angle, angle, side. I have 2 angles and the side not between them. 2 angles and the side not between them. And there we have it. That's the lesson. We're going to take some quick notes, and then we're going to get out of here. Here we go. First main point. If 2 triangles have 2 sets of congruent angles and 1 set of congruent sides, then those triangles are congruent. That's it. Let's recap our 2 main shortcuts from today. I had angle, side, angle, and angle, angle, side. Those are my two. Notice they both include two angles and one side. That's just what this paragraph is kind of summarizing up. Now, take some time and work through these problems on your own. Note, do not do number 3. It's a proof. We don't work through proofs in this course. But if you want to give it a shot, go for it. If you guys need anything, please feel free to send me an email, as I'll be checking my email throughout the day today. If you have questions or need to come talk, I'll be in class on Friday.